So thank you, Shalini, for the introduction and also for this opportunity that you gave me to share my experience in this small talk. So I'll just mile down this whole conversation from being so technical to just the humanities perspective. So in this presentation, I'll be explaining about the AI tools that I used during my research and which has helped me a lot in data collection and the literature review and further this analysis. As it is very evident compared to the science subjects that researchers in art and humanities usually face the challenge of making sense of large amount of data that is available today digitally. And digital humanities is a way to just tackle this challenge and provide a wide range of computational tools and different approaches such as topic modeling, textual analysis, network visualization, etc. And this quite recently, library science, as I'm a library science discipline student, it has also started to incorporate
Sorry,
data
Saloni, are
analysis.
you changing slides? I'm sorry, the slides are not changing.
Yes, I'll change plans.
Okay, thank you.
Incorporating this data analysis techniques like topic modeling and metadata analysis using these text mining techniques. So if we put digital humanities in a simple sense, it is the integration of modern computational techniques into the traditional subjects of art and humanities. And it explores and to explore and understand the content that is latent content or latent themes that are present within the data into any given data set. So that is these technical tools help us uncover hidden patterns present within the text, and further, it enables us researchers to understand and discover new insights from these literary texts and just explore new themes and topics. So to do so, we have a few commonly used methods like textual analysis, data mining, data visualization, citation annotation, critical annotation, sorry, and spatial humanities, linked data. So I'll be covering textual analysis and data mining. Data visualization is also included in this, and that which I will just later on explain when I'll be giving a demo of this VOS viewer. Critical annotation is something like when you annotate or critically add a comment to any digital text or literary text. And spatial humanities is basically this GIS mapping that we are using. And linked data is very important. I don't know whether you have seen it or not. In Google, we have this small section of art and culture. Google's art and culture section is there. That is the biggest example of this DH project, where all the historical events and these historical places and events and peoples are interconnected to present a holistic view of any particular historic event. So back in the, I'm not that technical, but it uses RDF, this description framework, where all the data is interconnected to it to just provide a comprehensive overview of the things. And nextly, if we go to, if we say digital humanities, when started in initial phase, it was all textual analysis of the literary texts, as we all know. So I'll be covering this textual analysis, and but then as the discipline just gradually developed, it also tried to incorporate other approaches to analyze this text, like data analysis, topic modeling, network analysis, and visualization, and now the deep learning and AI. Recently, in our discipline, also natural language processing has also gained significant traction. And so I too had to try, and I tried and implementing these techniques to understand my data that I used for my study to more efficiently to understand what it includes and what are the latent themes that are present in that. So other researchers can work on that thing also. So my research topic was university industry collaboration among the research institutions in the field of India in the fields of basic and applied research. It was a scientometric study, and in scientometric studies also they have started to integrate these NLP techniques to comprehend the data in more depth. That is, they try to identify these significant terms and themes again. But before coming to this data analysis part, we need to have a proper data. So for that, these AI tools helped me a lot to collect the data, like Open Alex, Web of Science, and Semantic Scholar. So we had this Semantic Scholar. These AI tools, these tools are this AI discovery tools where they just read out the semantics and they just try to analyze the meaning of those content, apart from this conventional bibliographic coupling or co-citation coupling that used to be there in our field to present the relevant documents. Semantic AI uses these semantics and try to find out the meanings, and then related to that, they try to just give us the relevant documents as per that. So it was very helpful for me to just know the research field and the related literature. And whereas for literature review, I used Elicit AI and connected papers and litmap. And there are other tools also, free open source tools that I use for literature review, where they provided just or just seminal papers from the topic that I just chose for my research. So those are the conventional tools where they just use this citations and references to just provide a structure of mapped structure of this literature in the particular domain. So, as the main focus of my research is related to the text analysis. So, WAS is basically a concept. The VOS is a similarity, visualization of similarity. It's a concept, and
Saloni, one
it
minute.
was used. Okay, okay. So I'll just quickly just give you a demo. Oh. So I use this WAS viewer. This is the basic interface of WAS viewer, where we just use this, create a map based on text data to just create a co-occurrence map based on the textual data. In this, then we had selected this bibliographic database file, because we use the Web of Science to collect the data. We just downloaded the data in a plain text form, to import this. So we'll just import the file. This is the plain text file that I used. And we have to mark these options as we have many times we have this structured abstract to just so that we can have misinterpretation. So we need to just check it out. So no misinterpretation interpretation happens. This is the way this extracts the data from your title and abstract, from apart from this conventional bibliometric analysis, where they use the affiliation, author details, and other citation details to just present analysis. So it will extract the data and then it will present a relevancy score. So basically, the relevancy score is never proportional to the occurrences. So on the basis of occurrences, the network map is created in WAS viewer. But the thing, if we want to go into the depth, then we have to consider the relevancy score. Relevancy score is basically not is related to the more specificity of the terms that are present in abstract titles, whereas occurrences is very generic. So to have a more in-depth analysis, we use this. So we will go for the binary counting, as it counts only a term for once in the document, whereas full counting counts for this the occurrence of term within the whole document. It concludes the total number. So it's better to take binary counting. So it is the binary counting that it's calculating the relevancy score. The thing that earlier I was telling, it is like this. If you have the highest occurrences, but you will see that relevancy score is very low. But if we just arrange it according to the relevancy score, then these are the more specific terms that are being used in the abstracts and title of these publications, or the total records for a given particular domain. So this is the interconnected network map that is being created for the data set that you will we have in this. So this is the map that has been created, but it's not that correct. But I have shown you how you can just analyze your text. So we know that this topic modeling, this thing, that clustering that is being done, it is a unsupervised technique, the NLP technique that has been used in the back end of this was viewer. I'm being from the non-technical background. I used was viewer as it was very convenient for me to use, and it has a very user-friendly interface, and it is very scalable as it handles a lot of data in the real time. And if from the subjective basis, if I tell, this is a very compatible for bibliometric analysis, and mostly all the discipline library science researchers use this. Apart from that, if you want to analyze, I would suggest that my slr millet r programming and python gensim, like you have in this python, and other natural language toolkit is there also to analyze you, to implement these kind of topic modeling to your results. Thank you. If
Thank
you
you.
have